Hello and welcome back to Harry Does Data. I'm Harry Norton and this is my series on R programming for beginners. Today we're going to take a look at character and logical data types. Character data types help us deal with text-based data, and logicals are important for evaluating conditions and getting code to perform in different ways based on those conditions. We'll be using these two data types a lot throughout the rest of the series. So let's get into it. But before we do, don't forget to give that like button a quick tap and subscribe to my channel so that you don't miss out on more great data science content. Character data types are generally used to represent text, so we could have something such as first name, so an object called first name, and that would be equal to Harry. Giving myself a capital H there. To define a character data type, you put your data in between these double quotation marks, and if I run that, you'll see that up here in the global environment, we have a new variable, a new object called first name, and it is of the character data type, and the value is Harry. We could define a new one called second name, and give you up the value Norton. And characters can pretty much include any character within them. So we could, let's say, have a password object, and within that we could use numbers, letters, characters such as exclamation marks or at symbols, and symbols, or even stars. And you can see that these, or even spaces, and you can see that these are all contained within the character. One thing to note is that characters are, however, case sensitive. So, for instance, let's have the character A, and if we do this, we will see that if we run is lowercase a equal to uppercase A, then the console will return false. If we run something like uppercase A greater than lowercase a, you'll see that that is true. So all that means is if you're going to sort a list of characters, then uppercase A would come before lowercase a. Now, I said you can use pretty much any character on the keyboard and save that within a character, but there are a couple of exceptions. If we wanted our character itself to have double quotation marks within it, this wouldn't be possible, because let's say we wanted to have Harry with the quotation marks around Harry like that, then you'll see that what happens is the character gets opened and then instantly closed, and so this comes up with an error. And instead, in order to add a character such as this, we need to use something called an escape sequence. So escape sequences are initiated using a backslash. So if we wanted to have a string, let's just call this string. And if we wanted to have some quotation marks in there, we could have Harry data Norton. And to view how that would actually look if we were using it, we can use a cat function. So cat string. And you'll see that that's printed Harry data Norton. I've got a little space that I didn't want in there, so we'll run those both again, and you'll see, yeah, there we go, Harry data Norton. There are several other escape sequences, so I'm just going to... So, as you might have realised, one issue you then have is, how do you have a backslash in your string without initiating an escape sequence? Well, it essentially just means using a double backslash. So if we run that one, you'll see that we have Harry Norton, and then we've got our double backslash in there. If you want to go to a new line within your string, then you use \n. So this should print Harry Norton on two separate lines. \t gives you a tab, so you'll see that's printed with a tab between. And \b actually does a backspace. I've not seen anywhere that I'd actually want to use this yet, but you can see that deletes the y character from my string. On our numeric data, we performed a lot of basic operations. And as I said, a data type of something defines what you can and can't do with that piece of data. if we try and run a basic operation similar to an addition for like a numeric piece of data on our character piece of data, then you'll see that we get an error. So we could do first name plus last name, or second name, sorry. And just another little hint for using RStudio, when you begin to type a object name out and you already have that object saved in your environment, then it will give you an auto-completion list, and you can just use the arrows to scroll up and down that list and press tab to select that one, and that just saves a lot of time in typing. But yeah, back to the character operation. So let's try and do first name plus second name. You'll see that doesn't work, that throws out an error. And similarly, if you wanted to do something like first name times second name, then that wouldn't work either. You can't do basic operations like this on characters, but for what you might expect that to do, so you might expect that to put the two strings together. That's where functions come in, and there's a lot of useful functions for strings or character data types, and we'll go through a few of them now. The first function that we're going to look at for characters is the number of characters function. So it's written nchar, and we give it an argument of first name, so x equals first name, and you can see it will return that the object first name, which is Harry, has 5 characters within it. Moving on to concatenation. So this is the one that we want if we want to sort of add 2 characters together. There are a few different concatenation functions, but the main one that we will use is paste. So we could do paste first name, second name, and you'll see that pastes the 2 strings together. You may hear me refer to strings and characters. They are generally called characters when you're using R, but this kind of data is often called strings in other programming languages, so I might use them interchangeably. They essentially mean the same thing in this context. Anyway, back to paste. So you'll see that the function pasted the 2 characters together with a space in between them. Now you can actually change what the value they're pasted together with is. Let's just copy and paste that from up there. So we can do paste first name, second name, and then define the parameter set. So set is equal to dash. You have to put it within strings itself. It needs to be another character. And if we just run that, you'll see that now our 2 characters are separated by the hyphen. You can even just have nothing in there, and then it'll paste them directly together. Another function that we might be interested in for strings is the substring function. And essentially all the substring function is for is subsetting a particular part of the character. So if we do substring, or substr, sorry, give it our first name, so x is equal to first name, and give it a start value. So at what point along that string do we want the substring to start? So the 1 in this case would be the H of Harry, and a stop. Put a comma in there, and a stop value. So let's go with 3. And if we run that, you'll see you get the first, second, and third characters within the Harry character. Or we could change this. So let's do 3 to 6. And you'll see you get the last 3. Obviously, there is no 6th character. So that is no different to doing 3 to 5. But it doesn't throw up any errors. It just only gives you the characters that are actually there. One final function that we are going to look at when it comes to character data types is the sub function. And this is essentially for replacing a part of a string. For instance, sub. You will see here the arguments that the function takes. So it wants a pattern. Let's give it pattern is equal to har. Again, these all need to be in strings. It wants what to replace that with. So let's replacement equals bar, and let's try that. oh no, we need to give it a string to actually operate on. So let's give it x equals first name. And you'll see that it is subbed the har for bar, and we now have Barry. But that hasn't saved that, so if we now just ask what is first name, you'll see that it's still Harry. So if we want to save that, we would have to reassign that value. So first name and then our function. So we will assign the result of this function to our object first name. And if we run that, you'll see that the first name object has now been changed to Barry. So if we do this on a slightly shorter string, let's use second name, and we'll sub all of the O's. So there's 2 O's in second name, 4 A's. Make sure we change this bit to second. And now you'll see that the sub function has only actually changed one of those O's. So it will change the first instance that it comes across. In order to get around this, there is another function. So if we just reset that back to second name being Norton, there is another function which is gsub. So if we just put the g in front of there and run that again, you'll see that that replaces all of the instances of that substring within the main character. And that is everything we're going to look at for strings. So moving on to logicals. Logicals are a slightly different data type. They are essentially used to define whether something is true or not true, or a condition has been met or has not been met, or something is on or off, basically anything that has 2 possible states. For example, we might have an over 18 object, and this is sticking with our theme of sort of data about a person. So as you can see, we've got a first name and a second name so far, and a password associated with that person. So let's have a logical defining whether they are over 18 or not. So that may be true. So over 18, we can assign that the value true. And you'll see that over up here, the over 18 object is a logical, and it has the value true. We could also have good at R. So is someone good at R? Is this person good at R? Maybe that's false at the moment. Hopefully by the end of this course it will be true. But you can see that good at R is a logical with the value false. You can also assign logicals using single letters. So we could do over 18 again and assign that with a big F. And you'll see that that has then updated the over 18 to false. And similarly, let's update the good at R to be the other way around. So we can use a capital T, and that has updated to true. One place that you'll come across these logical data types a lot is during logical comparisons. So let's just quickly define some data points. So x is equal to 7, y is equal to 4, and z is equal to 7. So we actually used a logical comparison earlier on up here, where we were checking is lowercase a equal to uppercase A, and we were returned the logical data type false. And so we can use that logical operator, which is a double equals sign, to do any of these kinds of logical comparison. So is x equal to y? I haven't run this, so these objects have not been stored yet. So let's just quickly run that, and now we'll see we've got objects x, y, and z. So try again. Is x equal to y? You can see that that's false. Is x equal to z? True. Similarly, you can have a not equal to logical comparison. So all that you do there is the logical operator is instead a exclamation mark followed by an equals sign. So if we run is x not equal to y, that is true. So it is true that x is not equal to y. Similarly, is x not equal to z? That's false because x is equal to z. We can also use other logical operators such as a less than operator. So I'm just going to copy and paste them down again. And this is the less than operator. So is x less than y? No. 7 is not less than 4. Is x less than z? No, because again, 7 is not less than 7. So maybe is y less than z? True, because 4 is less than 7. And again, let's try that with greater than. So that's just simply the opposite symbol. So it is true that x is greater than y. It is false that x is greater than z because 7 is not greater than 7. And similarly, is y greater than z? No, because 4 is not greater than 7. If you want to have a less than or equals to, you simply do the less than or equal to. So we can run all of those, and x is not less than or equal to y. X is less than or equal to z because x is equal to z, and y is less than or equal to z because 4 is less than 7. And you probably get the gist of it by now. We can have exactly the same thing, but greater than or equal to. And I won't bother going through the results, but yeah, you can assign greater than or equal to using that operator. Getting close to the end now, we move on to multiple comparisons, and I've got all of these just pre-written out here because they're a bit fiddly. But multiple comparisons are these operators that are used to check if several conditions are true. So this overall statement will only be true if both the first part and the second part are true. We can see that in action. So is x equal to 7 and y equal to 4? Yes, x is 7 and y are 4, so that should come up with true, which it does. And you can also just run this true, and you'll see that that comes out with true. If two things are false within an AND statement, then that will obviously lead to false. So is x equal to 6 and is y equal to 5 should come out with false because they are both false. And if any one thing is false within an AND statement, then the overall statement is false. And then finally, just to illustrate that point, x is equal to 7, so that is true, but y is not greater than x because y is 4 and x is 7. So one of these statements within the AND statement is false, so the whole statement is false. And then similarly, but with a subtle difference, is the OR multiple comparison, where if one of these statements is true, then the entire statement is true. And this is done using this, I actually don't know what this character is called. If you do, let me know in the comments. But essentially it's the one located next to your left-hand shift key. So if you press that left-hand shift key and that one next to it, then you'll get that operator. And so if we run this statement, we'll see that it is true because one of x equals 7 and y equals 4 is true. In this case, both of them are. If both are false, then that will again come out with false. And if both are, if one is true and one is false in this OR case, then it will be true. Now you can string as many of these multiple comparisons together as you want, and they do get quite complex sometimes. And you can use brackets to define the order in which they are carried out. So yeah, I'm sure we'll come across some fairly complex situations where these multiple comparisons are very important. And that is us getting towards the end of this tutorial. So we have looked at objects and how to define them. And we have looked at the three main data types or object modes that are used within R. And if we check our environment over here, we can see that we have several objects assigned with lots of different types of data. And this is all great, having lots of different pieces of data stored in lots of different objects. But what we can do is store all of these pieces of data within a data structure. And that is what we will be looking at next time. So we might have a data frame. And if I just run this, I'll give you a sneak peek at what we are doing next week. So I now have an object assigned data frame. And if I open that up, see it opens up over here. I have a data frame where each of the columns is one of our objects from over here. And each row could represent, for instance, one person. So I might have a second row down here with another person's names and their password and whether they're good at R and over 18. And this is where the true value of R starts being apparent. And this is where we'll actually start being able to do some data analysis. Don't forget to give this video a quick like and subscribe to my channel so that you don't miss out on the next tutorials in this series. Thanks for watching and see you next time.